Our study looks at the temporal dynamics of neural responses to monetary rewards experienced in social contexts. It's based on the growing literature surrounding social reward processing, which has found the ability to experience social relationships as intrinsically rewarding to be associated with a host of positive physical and psychological outcomes. Key regions and networks implicated in the processing of social rewards include regions of the general reward circuit, such as the ventral striatum and ventromedial prefrontal cortex, as well as the default mode network. Our research group previously demonstrated that rewards shared with close social agents, such as a friend, resulted in greater activation in the ventral striatum than did those shared with a stranger or computer. However, the question remains as to how these various responses might change over time. We applied secondary analyses to two data sets, which utilized shared monetary reward paradigms for a total N of 46 participants. One of the data sets involved the simple monetary outcome task, and the other was a trust game paradigm with monetary outcomes. Outcomes from both studies were experienced with a friend, stranger, or computer. After pre-processing our data, we applied a general linear model with regressors for both positive and negative outcomes experienced with each partner. We also included standard motion parameters, frame-wise displacement, cosine basis functions, and physiological noise as covariates of no interest. We then applied a finite impulse response model to a 10-second window with 5 bins of 2 seconds each, following outcome receipt to probe the time course of the bold response during social and non-social outcomes. We utilized t-tests to examine differences between the social conditions in a priori regions of interest, the ventral striatum, and the MPFC. Finally, we applied exploratory whole brain analyses at the 5th time point, TR5, for the contrast of social, representing combined friend and stranger, relative to non-social or computer conditions, and friend relative to stranger, to look for sustained activation anywhere in the brain for these contrasts. Results were corrected at the cluster level at a threshold of greater than 3.1. In our region of interest analyses, we found significant activation differences in the ventral striatum between social and non-social partners at both TR3 and TR5, representing approximately 4 to 6 and 8 to 10 seconds after stimulus onset, respectively. We also found activation to be stronger for rewards shared with friends relative to strangers at TR3. In the VMPFC, we found responses to social relative to non-social partners to be enhanced at both TR3 and TR5, as well as greater activation for friends relative to strangers at TR5. Our exploratory whole brain contrasts of social to non-social and friend to stranger rewards, specifically at TR5, showed recruitment of a number of regions within the DMN. The medial prefrontal cortex and posterior cingulate cortex were implicated in the social to non-social contrast, while the temporoparietal junction was recruited in the friend to stranger contrast. These results increased the specificity of our previous findings of the ventral striatums integrating the value of social relationships with reward value. Specifically, the finding of sustained activation in the ventral striatum, VMPFC, and DMN at TR5 suggests that there is a prolonged encoding of the relative value of rewarding experiences shared with friends. These results can have important implications for mental health conditions characterized by difficulty experiencing positive social experiences as rewarding, such as depression, autism spectrum disorder, suggesting that differences may not only lie in the intensity of these individuals' neural responses to these stimuli, but in their ability to actually sustain the signal. Future studies should utilize similar paradigms and analyses to extend these findings to such clinical populations. Thank you for listening.